For decades, the very notion of human settlement on another world has powerfully transitioned from speculative science fiction into an active, complex scientific pursuit. As our home planet confronts increasingly urgent environmental shifts and the strain of a growing global population, our scientists are logically turning their gaze outward for potential havens. This outward projection is not just a scientific hobby, it represents an absolutely vital strategic pivot point for the long-term continuity of the entire human race. We are now forced to grapple with the massive question: is establishing a lasting, self-sufficient outpost on the nearby red planet an entirely achievable, world-altering success story or an impossibly expensive dream? Understanding the core requirements for life to spontaneously emerge is far more than just an interesting academic exercise for biologists. The single most fundamental prerequisite for any known form of biology to take hold is, without a doubt, the steady availability of liquid water. A world must orbit precisely within its star's Goldilocks zone, a region where surface temperatures are moderate enough to maintain water in its liquid state. Should a planet drift too near its sun, all that precious water boils away into vapor too far, and it simply freezes solid into unusable ice. Equally non-negotiable is the requirement for a sufficiently substantial and stable atmosphere to cushion the surface environment. This gaseous blanket is necessary to efficiently regulate the planet's extreme temperature swings and to supply essential gases like oxygen and carbon dioxide for respiration and plant life. Furthermore, that protective layer plays the crucial role of shielding the surface inhabitants from dangerous, high-energy cosmic and solar radiation bombardment. Other determining factors that significantly influence habitability include the planet's overall mass, its operating temperature range, and the presence of a powerful global magnetic field. The relentless search for these worlds beyond our own solar system utilizes incredibly advanced orbital telescopes and specialized detection instruments. Major scientific endeavors, such as NASA's Kepler mission and TESS, have successfully cataloged thousands of promising exoplanetary candidates already. The revolutionary James Webb Space Telescope is specifically designed to perform detailed atmospheric analysis on these distant worlds with unprecedented precision. JWST actively scans for unique chemical signatures such as methane or oxygen, which could serve as powerful evidence pointing toward existing biological processes. The investigation is not solely focused on planets light years away. Scientists are diligently examining compelling targets right here in our own cosmic neighborhood. Icy moons like Jupiter's Europa and Saturn's Enceladus are prime candidates because they appear to shelter vast, potentially life-sustaining oceans beneath their thick, frozen shells. Detecting complex organic molecules or signs of underwater hydrothermal vents suggests conditions right now might be suitable even for simple microbial organisms. Upcoming exploratory efforts, including the dedicated Europa Clipper mission, are scheduled to probe this incredible possibility with dedicated instruments in the near future. When considering colonization within our own solar system, Mars stands out as the most immediately viable and realistic target for establishing a long-term human presence. Its relative closeness to Earth, coupled with a rotational day cycle very similar to ours, offers significant logistical and physiological benefits for early settlers. Amazingly, the actual surface area of the Martian globe is almost equivalent to the combined landmass we currently occupy here on Earth. Additionally, the planet offers a surface gravity that is about 38% of what we experience daily, which is a measurable advantage for human physiology. Positive readings from various robotic explorers continue to sustain the compelling hypothesis that liquid water exists, perhaps deep underground or even beneath frozen polar caps. Mars is also strongly suspected to hold significant quantities of necessary mineral resources, with confirmed proof of various essential metal ores already identified. However, the Martian environment presents truly daunting roadblocks that must be meticulously overcome before any permanent settlement can thrive. The atmosphere is shockingly thin, roughly 1/100th the density of Earth's, and is overwhelmingly composed of unbreathable carbon dioxide gas. This meager air offers virtually no substantial defense against the constant influx of lethal space radiation, or any means to sustain respiration for humans. Temperatures plummet to absolutely frigid levels, with an average surface reading hovering around a bitter -60 degrees Celsius. Adding to the toxicity, the very soil, or regolith, is laced with hazardous chemical compounds known as perchlorates, making agriculture immediately unsafe. Conquering these colossal obstacles demands the immediate development and deployment of completely radical, unprecedented technological solutions. Initial plans center around constructing vast, pressurized, self-contained habitats, perhaps resembling transparent geodesic domes or underground bunkers. Key life support involves future scientists devising methods to process the thin carbon dioxide atmosphere to extract usable oxygen for breathing. Generating necessary potable water will depend heavily on tapping into confirmed, accessible subsurface ice reservoirs scattered across the planet. Ambitious, real-world programs like NASA's ongoing Artemis initiative and SpaceX's developing Starship are vital concrete steps pushing us toward this ultimate goal. Looking further ahead, researchers are dedicating significant effort to the long-term concept of terraforming, the total modification of Mars to resemble Earth. Even under the most optimistic projections, experts currently estimate it will take a minimum of 2 to 3 decades before we can realistically establish a truly sustainable human settlement on the Martian surface. Proponents passionately argue that sending humanity to multiple worlds is an essential insurance policy against any single world-ending catastrophe here on Earth. Moreover, the massive technological push required for space colonization frequently yields unexpected beneficial spin-offs that improve life right here at home. Some view this expansion as the inevitable continuation of humanity's inherent cultural drive, echoing the great voyages of exploration from centuries past. This monumental endeavor serves as the perfect necessary stimulus to re-energize contemporary society and reignite a collective can-do spirit among us all. Currently, the primary international legal guideline governing activity beyond our planet remains the foundational Outer Space Treaty. This key document explicitly forbids any single nation or entity from asserting sovereign ownership or claiming territorial rights over a celestial body like the Moon or Mars. Critically, however, the treaty does not explicitly prohibit private corporations from traveling to Mars or establishing long-term permanent residential settlements there. The moment we successfully build a continuous Martian colony, an entirely new, complex framework of space law and international regulations will absolutely need to be created. Any early Martian outpost would logically operate under a status similar to international waters, belonging functionally to no single terrestrial government. Recent legal adjustments by nations like the United States and Luxembourg have already postulated that private enterprise can indeed utilize and profit from extraterrestrial resources. A significant ethical hurdle revolves around many colonization proposals that feature volunteers signing up for a non-return or one-way voyage to the planet. A major legal quandary arises if a colonist experiences a serious mental health crisis or severe illness and then tries to revoke their original, irreversible consent for repatriation. While technically possible in the early days, physically retrieving a distressed colonist would likely become astronomically expensive and logistically prohibitive. This situation immediately forces us to deeply examine fundamental human rights, particularly the inviolable right of every individual to freely choose where they reside. The reproductive rights of any individuals choosing to settle permanently on Mars must also be proactively addressed by international bodies. Children born on the Red Planet would likely inherit the Earth citizenship of their pioneering parents, creating a complex jurisdictional status. These Martian-born citizens would face inherent isolation, severely limited access to resources, and a profound lack of choice regarding their future education or career path compared to their Earth counterparts. We must urgently rationalize whether we are ethically prepared to deliberately sanction a life defined by such restriction and confinement for individuals who never consented to it. International conventions like the Convention on the Rights of the Child mandate that governments ensure every child has a chance to survive and develop in a healthy and adequate standard of living. Martian colonists will inevitably be subjected to pervasive, constant monitoring and surveillance inside their habitats, which severely magnifies psychological burdens. This enforced lack of privacy, combined with physical confinement and deep social separation, is known to trigger significant psychiatric distress in isolated groups. Such stress can manifest as short-term self-preservation behavior, increased interpersonal abrasiveness, chronic stress, and even suicidal ideation among the crew. Settlers will trade the relative openness of a spacecraft for a base environment that is equally small, perhaps only 50 square meters allotted per person for the majority of their time. Experts point out that these crews will lack crucial psychological buffers, such as real-time, intimate contact with family, or the immediate safety net of a return option. We also face a profound ethical responsibility should any indigenous Martian life, even microscopic extremophiles, ever be definitively discovered on the planet. Current international space law already imposes a requirement on signatory states to avoid any form of harmful contamination of other celestial bodies in principle. Colonization, and especially large-scale terraforming, inherently involves massive, irreversible environmental alteration through the extraction of local raw materials. Planetary protection policies are actively designed to stop this cross-contamination, but it remains unclear how our survival imperative would ethically balance against native life preservation. The ultimate passage toward a second home is inherently long and fraught with unknowns, demanding a delicate balance of physics, chemistry, and geology. We are rapidly gaining the technological prowess to reach the stars, meaning we will encounter complex moral dilemmas much sooner than anyone initially predicted. If humanity can successfully manage to preserve the delicate ecosystems and functional integrity of our current planet, we fundamentally safeguard the whole of human consciousness and our core values. We absolutely must ensure that the inherent light of consciousness we carry is brightly maintained and proven worthy of exploring this spectacular, enigmatic universe. The final overarching quest is not merely about the physical act of reaching another location. It is about the kind of advanced ethical civilization we ultimately choose to embody.